Hello, Jump students. Welcome to lesson 1-8 on indirect proof. So this is a kind of an oddball topic in geometry, um, but it is kind of important because I think in real life it's really hard to always directly prove something. So you can kind of come to a result using roundabout thought processes, and this is what we're doing here in indirect proof. Okay, so let's do an example here to get your mind thinking indirectly. So it says Beth is having dinner with Sarah, one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a chicken and spinach pizza to share for dinner. Who was having dinner with Beth? Okay, so we have these three possible candidates for dinner. To do this, we're going to use what is called process of elimination, right? I'm sure you guys have uh, used process of elimination sometime in your lifetime, right? So let's go just in order. So let's talk about Libby. Well, it says here, Libby is a vegetarian, right? Doesn't eat meat. Well, if we look at this, right, they order a chicken and spinach pizza to share. I believe that chicken is meat. If Libby can't eat chicken, then I don't think Libby is there at dinner. All right. Next, let's talk about Mercedes. So Mercedes is at the library. Now, it doesn't tell you the location of where this dinner is occurring, but I don't believe that they're having dinner at a library. I think they're at a restaurant. So because Mercedes is at the library, she can't be at dinner. It's not Mercedes. Therefore, Kelly must be the one. And all you know about Kelly is that she's allergic to mushrooms. Well, there's no mention of mushrooms on this pizza at all. So I believe that Kelly is at dinner. And there we go. So in this problem, we did not look at Kelly first. We looked at the other two and talked about why they couldn't be. So why they can't be means that Kelly must be, right? Process of elimination. So we're going to talk about indirect proof writing, and the first one is going to be indirect proof by contradiction. Now, when you talk about indirect proof, the reason we use indirect proof is because direct proof is impossible. A lot of times in math, it's very hard to prove everything directly, right? There's a lot of different possibilities. So maybe there's only one possibility that's not, and we prove something about that, right? So we limit the amount of work we have to do. And again, there are two types. There's contradiction and contrapositive. We're going to focus on contradiction right now. So when you do a proof by contradiction, the first thing you do is you're given a statement, a conditional statement, if P then Q. You are going to assume that P is true and not Q is true. You're going to negate the conclusion. Once you do this, you now need to show that the assumption not Q leads to a contradiction. And this contradiction is usually about P or some geometric idea. Right? Something that we know is a proven idea that it goes against. Once you reach this contradiction, that means that not Q can't be true. And if not Q can't be true, then Q must be true. And that's how you arrive at your conclusion. Okay, so let's take this idea and try to transform it or apply it to this proof by contradiction. So it says, write an indirect proof of the following statement using proof by contradiction. If Alani walks more than 8 kilometers over a 2-period day, then she walks more than 4 kilometers on one or both days. So here's your if P then Q statement, right? So P then Q. So we need to negate the Q. So we need to assume Alani does not walk uh, more than 4 kilometers on either day. So what we just did there is we just negated the Q, right? We negated this idea of walking more than 4 kilometers on one or both days. The only other option is not walking more than 4 hours on either day. So if she walks, so not more than 4, could mean 4 each day. So 4 plus 4 is 8. Or it could mean less than 4. So like 3 and 2, 3.5 and 2.75, whatever. But anyway you slice it, even 4 and 4 equals 8. Could not be more than 8, right? This says she walked more than 8 kilometers. That's the contradiction. So we're going to say, therefore, her total distance is less than or equal to 8 kilometers. Right? But you see it says more than 8 kilometers. This must be true. So this is your contradiction. However, this contradicts the given idea that Alani walks more. I feel like I'm writing a lot, so maybe you could say this contradicts the given walks more than 8 kilometers over 2 period day. So because we arrived at this contradiction, that means that Q must be true. The idea that she walks more than 4 kilometers on one or both days must be true. So we say, thus, Alani must walk more than 4 kilometers on one or both days. And there you go. And that's your proof. Okay. So you assume the conclusion Q is not true. You contradict either the given or the conditional part P or some idea in geometry, and then you say, thus, the Q must be true. Proof by contradiction. Great. All right. Next video coming up talks about proof by contrapositive. Woohoo!